All right. Here we go, guys. Here we go. Sorry for the little delay there. All right. So we've already done antiderivatives. All we're going to do now is we're going to evaluate definite integrals. When you're evaluating them, it's antiderivative of upper minus lower. And don't worry, we're gonna talk about that, what that is. So because they're defined, you're no longer going to put the plus c. Now you're still going to use the plus c whenever they have no limits, but these all have limits. Cool or not cool? All right, so I'm going to put an equal sign. I'm going to put this in tablet mode because it's kind of, okay, there we go. So what's antiderivative of sine x? Okay, someone said cosine x. Is it positive or negative? Oh. It's negative because the derivative of cosine is negative sine, and I don't have negative sine. I have a positive sign. Do you guys see that? So it's negative. Now, in the math world, we put, if it has limits, you put a line like this. That means evaluate, to evaluate it. And usually put a 0 on the bottom and a pi on the top. Now, I have seen some textbooks that do this. So don't write this down, just listen. That do this. They put this in bracket, and they put the limit like that, 0 to pi. And you can do that. They're not going to count it wrong. It's fine. But technically, to be technically correct, it's not a bracket. It's a line. And it's upper minus lower, like that. Now, when you do that line and you're going to evaluate, so I'm going to put equal sign. You do the upper minus lower. So what does that mean? It means this. I'm going to write negative cosine of pi, close, minus, and then lower, negative cosine of 0. So cosine of pi is negative 1, but I have a negative in the front. So that turns it into 1 minus cosine of 0 is, cosine of 0 is 1, but I have a negative there, so I have it like this. Minus a negative turns it into a positive, so this is 2. And that's it. That's it. We're just using the formula because we have limits. If we didn't have limits, we put plus c. Oh, sorry. It's because I printed them myself, and then I had to staple them here. All right. So this question, I hope you guys remember it from a while ago. Was it like, what was it, 3 days ago, or was it last week? I don't remember. It was from a while ago. We found the area of the curve from t squared doing LRAM, MRAM, and RRAM, and then we let the number of rectangles go to infinity. And then we concluded, what did we conclude? That the area under the curve is approaching 9. Does that make sense? So I want to know, what did we conclude about the distance traveled? So we said distance traveled, I can't spell traveled is 9. 9 units if it doesn't have any units. Does everyone agree that the distance traveled is 9? All right, I want to know this. If I integrate from 0 to 3, so I'm going to put 0 to 3 of the equation v of t, which is t squared. So I'm going to put t squared, and because it's a t, I'm going to put dt. I want to know if I integrate t squared from 0 to 3, that if I get the answer of 9. Well, let's see. Equals, what's antiderivative of t squared? Yeah, add 1 to the degree. I'll add 1 to the degree, divide by that number, guys. I'm going to go ahead and put it in a bracket, just so you guys can see all types of forms. In the bottom, I put a 0, and the top, I put a 3. That means that I'm going to evaluate that. Are we still okay? I put an equal sign in the bottom. It's fine. Make sure there's no linkage errors or anything like that. And I do upper minus lower, the same expression. So here it is. Parenthesis 3 to the third divided by 3, close, minus lower. 0 cubed divided by 3, close. I know that 0 cubed divided by 3 is 0, but I'm doing this for habit, because if the lower limit was a 1, I would have put a 1. Cool or not cool? Okay, check it out. One of these 3's cancel out. You just get 3 squared. 3 squared is 9. And then, of course, this is just 0. OMG, that's a perfect area under the curve of TQ from 0 to 3. How do we feel so far? Nothing crazy, right?
So you can use antiderivative to find this?
To find the perfect answer, the perfect area under the curve of that curve, yes.
You don't have to do LRAM, MRAM,
No. I mean, unless, well, we're going to have to if they don't give us an equation and we have to approximate and stuff like that. All right, here we go. This time there's no context on the question. Come on, Ms. Rodriguez, focus, miss. There's no context on the question. They just want to know, can you do antiderivative and evaluate? So let's see. Antiderivative of x cubed is x to the fourth over 4. Antiderivative of 1 is just x. Sometimes when there's two variables like this, I'll see this. -1 to 3. It's fine if you do that. I see that very often on the AP reading. Yeah, but they want to show that those two are the elements. It's okay to write this. This is still correct. They're both the same thing. Are you guys still okay? All right. What did I mess up? All right. Equals. I do upper minus lower. So here we go. Giant parenthesis. I'm going to put the first. So I'm going to go 3 to the fourth power divided by 4 plus 3. Close. Am I done? Minus, open another parenthesis, -1, put that in parentheses so you guys don't get confused there, to the fourth power plus a -1. Close your giant parentheses. Let's see what this is. 3 times 3 is 9. So 9 times 9 is 81. 81 divided by 4. Is that a pretty number? No, right? 81 over 4 plus 3. Minus, let's see, this turns to 1/4 minus 1. I'm going to put this in the calculator real quick, guys. So here's my little calculator. Unless I feel like doing common denominator and all that good stuff. Let's see what we get. 81 over 4 plus 3 minus parenthesis 1/4 minus 1. I mean, I guess I don't need a calculator for that part. And I got a 24. Done. How do we feel, guys? Pretty easy? All right. Last example here, and then we'll set you guys loose with their easy activity. And it is due today, but it's easy, so you'll be fine. Yeah. Here we go. Antiderivative of 1 over x. ln of x. Remember that the derivative of ln of x is 1 over x? Okay, but sometimes you have negative limits, guys, and you would have to put ln absolute value of x, but we're good right now. So ln of x, and I'm going to evaluate this from 5 to 1, or 1 to 5, but I'm going to do upper minus lower. Oh, I just put a little bracket. You can erase the little edges.
Where's the other bracket?
Okay. All right, here we go. Equals ln of 5, upper, minus ln of 1. Yeah, perfect. Yes, ma'am.
So if that one was negative, it would be ln absolute value of x?
Yes, but we're not advanced yet, so I'm going to wait until we start talking about more advanced integration so we can talk about that. Equals ln of 5, because ln of 1 is 0. How do we feel? Yeah, that's it, guys. That's for today. Log into Delta Math. You have 10 questions. You're going to do 10 antiderivatives, and that's all we're doing.